Greetings, this is Mr. Caslin. We're going to talk about quadratic regression and how it differs from linear regression. The problem I'm going to pose to you today is this is just an XY table like we've been working with, and this data is from someone who threw a shot put. Okay, so when the shot put had traveled 7 meters, it was at a height of 8 meters. So notice as it's traveling, the shot put's going up and up and up. But guess what? Gravity starts influencing, it's losing energy, and the gravity's taking over, and now the shot put's going, the further it goes along, now it's starting to go down. And we want to predict where that, or how high that shot put's going to be when it travels 80 meters. Okay, so think what's happening is your shot put, as it gets pushed, it goes up, but it's losing energy and gravity is starting to pull on it, so it's starting to go down. It's going to hit the ground at some point. So we're do a regression to see if we can predict where it's going to hit. All right, now notice what I was drawing is a curve and not a line, so that's why we're going to try something different than a linear regression. All right, so this is a regression, so we're still going to put our data. We're going to go to Stat Edit, and we're going to load our table. Our X values are going to go into list 1. Our height values for Y are going to go into list 2. All right, so the same way we did with the linear regression, we're going to look at the scatter plot. So remember, we turned our stat plot on. We're still going to do that. We're still going to look at it. We're going to go to zoom 9, which is do a stat plot, and look at our data. Our data. So a linear regression would keep going up and up and up and up. Here, remember our shot put, gravity is taking over and starting to go down. So a line is not a very good fit for this data. But you're going to learn as you get into math classes, there's different ways we can fit data that's not always linear. We're going to use all these different functions that we're learning about. All right, so the first one, we're going to use, this kind of looks like a parabola that's upside down. Remember, an x squared function creates a parabola that goes up, and a negative x squared is flipped. It's not a very good parabola. That's a little better. I'm not very good at drawing with a mouse, so I'll have to find a better writing tool at some point. But so we want to try to fit this. We're going to try to fit this data with a negative quadratic. All right, so everything's pretty much the same thing that we did for linear regression, except when we go to Stat Calc, we're not going to use linear regression. We're going to use the one right below it, which is called quadratic regression. So when your teacher says, let's try a quadratic regression, they're talking about this one. We're going to say enter. Our X is in list 1. Our Y data is in list 2. So we're going to keep everything the same. We're going to calculate it. Now notice what's happening. Whoops, let's go back to the calculator for a second. Instead of y is equal to mx plus b, now we have ax squared plus bx plus c. Remember, that's the general form of a quadratic, okay? And it gives us our coefficients a, b, and c. By the way, these a, b, and c are the same ones you would use for quadratic formula. Okay, and I'm going to keep, if your teacher doesn't tell you, let's keep 4 decimal places with this. All right, so we're going to write down we've got this function now, negative 0.0111 x squared. Again, sorry, I don't write very well with a mouse. Plus 1.0596x. That was our b. And our constant was a positive 0.2422. All right, so that's our function. That's our f of x. Just so everything's the same except instead of having a linear equation, we now have a quadratic. And we expected it to be a negative x squared, remember, because our parabola is going down. Okay, so just the same way we did with our linear regression, let's see what this is going to look like when we graph it. Okay, negative 0.0111, x to the second. Hopefully I get all this right on the first shot. Plus 1.0596x. And our constant is 0.2422. Now there's ways to actually, when you create your quadratic regression, there's ways we can copy and paste this equation into here so we don't have to type it in. But we'll talk about that at another time. So right now we're going to graph this. We still have our scatter plot on. In this equation, see how it fits the data really well. This is a good predictor of our scatter plot. So instead of a line, we're using basically a quadratic curve. Okay, now there was a follow-up question and said, what would the height of the ball, at what height would the ball be if it travels 80 meters? So 80 meters along, it's going to be off the graph here, what's the height? So we're expecting this height to be less than 21 because we're starting to go down on this end. All right, so basically you're taking your function and you're plugging in 80 meters. So think of this as f of 80. All right, so we're doing a 0.0111 80 squared. There again, sorry about my writing. Here, we'll just, I think you'll get the point of it. We're plugging in 80 here. We're plugging in 80 here. So we're doing a substitution, and you're going to get, if you do that calculation, you're going to get 13.9702. Now it's a word problem, so we should do units. So our height is in what units? Looks like meters. So at a distance of 80 meters, the height is going to be 13 meters. So it hasn't hit the ground yet. Okay. Now, if you're trying to figure out in a different problem, if you want to know when it hits the ground, you're trying to figure out when the height is 0. Okay. So you plug in 0 for your y, and you're trying to figure out what x is. So you would use your quadratic formula to find your zeros. We're not going to do it in this problem, but you'd find. Remember, it's a quadratic. You'd get x is equal to 2 numbers. Now, in a word problem, you could get a negative and a positive number, and you would want to keep because you're talking about the distance. You want to keep your positive distance and throw away your negative distance. Okay, so let's review that real quickly. It's the same as a linear regression. We go ahead and we load our data, load our x's, load our y's into list 1 and list 2. We turn on the scatter plot. We would do a stat plot to see our scatter plot. We then calculate our equation. So you're doing a calc. Now the only difference between this and a linear regression is that we're using quad regression. Now when you get into Algebra 2 class, you're going to learn about these others. You can do a cubic regression or a quartic regression. There's lots of different functions. And if we keep going down, lots of mathematical regressions we can do to try to fit that data. I think for Algebra 1, we're just going to stick with the linear and the quadratic. All right, so we do our quadratic regression. All of these, yikes, what was that? Where'd we go? Okay, all of these will remain the same. We calculate it, and we get all of our coefficients A, B, and C. All right, so we get our formula. And then there's going to be a follow-up question, usually where you calculate a new x, and it'll give you your output of your function. Remember, your table function can also tell you different values. Okay, so I was doing this earlier, so I already went down to, so when the distance is 80, the output is saying that the height is 13.97 meters. Okay, I hope this helps, and let me know if you have any questions. We'll talk to you later.